Okay. So 4.3 is solving compound inequalities. So what we're doing is we're just solving inequalities and graphing them again, which is something we've already done, but some of our inequalities will be together. And it's just one different step that you will have to remember from what you've already been taught. Okay. So, yeah. Okay. Okay. So, we are gonna, all the steps up here, are to help you to maybe if you forget what to do, you can go back and read them. But sometimes you're going to see two separate inequalities and you'll graph two separate inequalities. Sometimes you will see one compound inequality, which is two inequalities put together, and you solve and you then just graph your solution from that. So let's look at example one. The first thing we're going to do is we're just going to solve these two inequalities. So I am going to divide both sides by 2. I get, oops, sorry. I'll make it bigger. I get x is less than 3. Okay. Then I solve the next one. Divide both sides by 2. And I get x is greater than or equal to -3. Notice that this is and. This is a conjunction. So our answer is both of these. Okay, so this would be our answer. And now we are going to graph the compound inequality. You're going to graph each inequality separately. So we are going to plot an open circle above 3. Boy, I made these number lines tiny. So an open circle above 3, and x is less than. So that's going to go in this direction. And then x is greater than or equal to -3. So I'm going to plot a closed circle above -3. Connect them. Okay. Let's go ahead and solve the next one. We're just solving the one-step inequality. Here, we're going to subtract 2 on both sides. Here, we're going to add 1 on both sides. So we end up with x is less than or equal to 6, and x is greater than or equal to -6. Now, it's not going to always be the same number, one positive, one negative, okay? So this is part 1 of our answer. And then part 2, we're going to graph it. So x is less than or equal to, that tells us it's going to be a closed circle above 6. Since it's less than, it will go to the left. And then x is greater than or equal to -6. So we're going to plot a closed circle above -6 and connect these. They're being connected because they are conjunctions. They have the word and, okay? All right, now we're going to go to a different type of conjunction where you have, oh, I'm sorry, where you have your two inequalities combined. So if I were to set these up, I would have 3x is greater than or equal to -9. That would be one inequality. And the other one would be 3x is less than or equal to 15. And I could solve them separately if I wanted to, but you don't have to. So on this one, I have to divide my -9 and my 15 by 3. So I divide the middle by 3, the left by 3, and the right by 3. I divide them all because our goal is to isolate the x in the middle. Okay. And we do that by dividing the middle by 3. But then if we divide the middle by 3, we have to divide both sides by 3. So I end up with -9 divided by 3 is -3. Bring down my symbol. I'm left with x in the middle, and then 15 divided by 3 is 5. Okay. Now, sometimes Again, sometimes students get confused by that, but if you think about this, this is, another way to write it is 3x is greater than or equal to -9, and 3x is less than or equal to 15. So if you prefer solving them separately, you are more than welcome to set it up like this and solve them. You'll get the same answer, except it won't look like this. It'll look like what we did up here, okay? Now we're gonna graph this. So I'm gonna have, since x is greater than or equal to -3, and I'm reading it from the x, I'm gonna have a closed circle above -3. And x is less than or equal to 5, I'm going to have a closed circle above 5, and then I will connect them. All right, let's go to example 4. Here, remember that we're isolating the x in the middle, and whatever we do to the middle of the compound inequality, we have to do to both sides. So I have to divide by 4 to isolate my x. That means I'm going to divide the left and the right by 4 as well. So 0 divided by 4 is 0. 8 divided by 4 is 2. Then I graph this. So this time I'm going to have open circles above 0 and an open circle above 2. Are there any questions on how to decide whether it's open or closed with these kind of inequalities? Okay, so x is greater than 0, so my arrow will go in this direction, and less than 2, so this will go in that direction. We'll just be connected. Okay, let's go ahead and go to page 2. So we have more of the same, except instead of multiplying and dividing compound inequalities, we are now going to add and subtract with them instead. And then we get down to 2 steps, and then on the back we have disjunctions. All right, so in the middle, to isolate our x, we do the inverse operation of adding 2 and we subtract 2. And whatever we do in the middle, we have to do to both sides. So we're going to subtract 2 on all in all sections of the compound inequality. So -6 minus 2 is a -8, which is less than x, which is less than 7. And we can graph this one. So I'm going to have an open circle above -8. And x is greater, so it's going to go in the greater than direction to the right. And then I have an open circle above 7 because the symbol next to the 7 does not have an equal sign. So that's an open circle above 7. And x is less than, so it'll go in the less than direction and connect my lines. Okay, why don't you go ahead and do example 6 on your own? I'll do it up here, but try it on your own and then check your answer when you get it done. Okay. Okay, when you're done, go ahead and check up here to see if you got the correct answer. Okay. All right, now what we're going to do is we're going to move to 2 steps. So we just did 1 step compound inequalities. Now we're going to do 2 step. Again, your goal is to isolate the x on the inside. And so like any 2-step inequality, we have to do the inverse of addition and subtraction first. So we're going to get rid of the -4 by adding 4. In the middle, on the left, and on the right. Okay. So -4 plus 4 is 0. The less than symbol, then we have 2x still left in the middle. less than or equal to 10. So that was our first step. Now our second step is to continue to isolate the x by doing the inverse operation of multiplication. And we are going to divide everything by 2. Okay. So now we're going to graph this. I want you to go ahead and graph it. We've done a ton of graphing, so we should start getting the hang of it. And once you check your graph, I want you to move to example 8 and try to do example 8 on your own. And again, I'm going to be working up here, but you can check your answer when you're finished or if you get stuck. Glad. Okay. Any questions on that one? Anyone still working on this one? Okay. This next one is actually a 2-step, and I put it on here for a reason. Remember, anytime you divide or multiply by a negative, it flips the sign. So this negative x right here is like a negative 1x. All right, so the first step here is we are going to subtract 1 on all sides. And we are left with a negative 5 is less than negative 1x, which is less than 7. Okay. Now, when we divide by this negative 1, as we're dividing an inequality by a negative, we're going to have to flip our signs. So negative 5 divided by negative 1 is 5. It's no longer less than, but greater than. Bring our x down. Flip the next sign. And 7 divided by negative 1 is a negative 7. Okay. And we graph this. Now, you're going to graph each one separately. So you'll graph x is less than 5. And then you'll graph x is greater than or equal to negative 7. Now, if you want to flip everything, this one, yeah. X is greater than or equal to negative 7. Because we flipped the sign, because we divided by a negative. So anytime you divide an inequality by a negative, you have to flip the sign. I know that, but it wasn't a greater than. Oh, it doesn't have a line under it. Oh, okay, okay. Is that what you're talking about, Solomon? Yeah. Okay, I'll get rid of that. Yeah, I put a line under it and it doesn't have a line. Okay. All right, so let's go ahead and graph this. We're going to have an open circle above 5. And x is less than 5, so that's going to go in the less than direction. And then x is greater than negative 7. That's going to go in the greater than direction, and our lines will meet. Okay? So those were all conjunctions.
Wait, how will they meet? Oh, it's negative.
Yeah, it's negative 7. So, and 2, you can always flip this to negative 7 is less than x, which is less than 5. Either one of those works, especially since all the rest look like this. But either answer is okay. Oh, I didn't box this one. Okay. All right, let's go ahead and move to the last page. On this last page, we're doing disjunctions. Same concept, except it's two inequalities separated by the word or. Okay, so we're just going to solve them separately. Now, this one right here is already solved for you. So x is greater than 2. Or you will subtract 1 on both sides here, just like we did on the previous page and lesson. And x is less than 1. Or x is less than 1. So now we're going to go ahead and graph these. Now, when we do disjunctions, the lines typically are going in opposite directions. So be careful with this. So I'm going to have an open circle above 2. And x is greater. So I'm going to draw my arrow to the right. And then I have an open circle above 1. And x is less than. So I have an arrow going to the left. Okay. Great, let's do example 11. Example 11, 3x is on what some of us might say the wrong side, but it doesn't really matter what side it's on. So on this one, I am going to move 2x over. So I'm going to subtract 2x on both sides. I'm left with 1 is less than x. Or you can write it as x is greater than 1. And this actually makes a little bit more sense to write it this way for some of you, but either way is okay. This one, we're going to subtract 7 on both sides. And we have x is less than or equal to -6. That is only when you multiply or divide by negative, not add or subtract. Okay, so then this is your answer. And we are going to graph this. Open circle above 1. X is greater than. Closed circle above -6. And x is less than. Okay, let's look at number 12. I want you to go ahead and solve both of these, or I want you to solve number 12 and graph it. And because we're short on time, I'm going to go ahead and solve it up here, but I would like for you to try it on your own just to make sure you're understanding. Okay, and then just check up here as you're going. Same thing again. Hey, you're dividing by a negative, so make sure you flip that sign. Right? Go ahead and check that. Questions? Anyone still working? No. All right, let's solve the last one, example 13. So here I'm going to divide both sides by 5. And I get x is greater than or equal to 9. And on this one, what am I going to do to both sides? Multiply by 2 or the reciprocal, however you want to say it. And we get x is less than or equal to 8. Okay. And go ahead and graph that. And that concludes lesson 4.3, solving compound inequalities.